I'm Drew Johnson, and one of the first aspects that we looked at when designing her recorder is which finger she's going to use, and we found it easier for her to use all 4 fingers on her right hand, which is not typical. Usually you use 3, but we found it would be easier for us to design the rest of the recorder if she used all 4. And when we met with her in class, we noticed that she had trouble reaching that 4th hole with her pinky because her pinky was a little bit shorter than the rest of her fingers. She kind of had to stretch her finger over to get to that hole. So we came up with this little design. It mounts on the side of the recorder. We're going to glue it on with ABS cement and make the actual apparatus out of ABS. So this just puts a little extension on the recorder so she can close that hole a little bit easier with her pinky. And then we have a little rubber dome here to close the hole. And this is going to be spring loaded, so it's going to spring up to keep it off the hole, and then when she pushes it down, it's going to close the hole.
Okay, and so this is the fingering chart that we came up with. So we made it so that the right hand is usually on the bottom, but we moved it to the top, and we're using the pinky for the 4th hole, so that our design is just dealing with the last 3. And I worked a lot on the recorder support, and we did, in the benchmarking, we found a cool patent for one on our clarinet. So that's what I based my design off of, and this is an older one. We've decided that we're going to use a twist and lock tube so that you can change the length of it instead of a set screw. And it's going to attach down to the very bottom of the recorder right there. And it's going to use a lanyard that hangs it down here so you can change the length as she goes and for different people.
In addition to the pinky support and the support for the bottom of the recorder, the final 3 holes are actually relocated to where her wiggle is. Previous designs, we tried to move the influence of her wiggle to the 3 holes, and this design is just meant to do the opposite, which is to move the 3 holes to her wiggle. And we have yet to create a prototype of this. Our biggest concern is that we'll have to find the optimal diameter for the holes, which pass from the top up here. Here's a side view, kind of goes down into the body. And it's designed to actually replace the tailpiece of the original recorder so that it's a slip fit, and it should be pretty straightforward to set up, and it should make it pretty easy for her to play.
So I'm Ian Redfern, and this is an exploded view of our assembly. You can just see it's kind of small, but this is Drew's extension attaching to the side, and then we have the manifold just attaches to the end piece and slips on to here. And then we have the support that attaches to the very end of the recorder. I did some of the human factors research, and I found a chart from the CDC, I think, that is the height and weight percentiles. I plotted her current height and figured out that she was in the 50th percentile, and just followed the line up to figure out what her height would be at age 11 and when she's an adult, so that our design meets her meets the requirements for her age for growing up. And then I also found an online human proportions calculator, so I could put in her height at any age, and it would give me her, like, the length of her arm. And I went back and checked. I put in her current height and checked our dimensions that we took, and it all matched up almost exactly. And then I used those to calculate how long our support should be. And so I figured out that at her current age, around 12 inches, and then 11 an adult, 13 and 15 and a half inches. So our support should be able to adjust, and within that range, she's playing at a 45-degree angle to accommodate her for the rest of her life. And then I also did a calculation on the torsion spring in Drew's design, and in the future doing spring calculations for our keys in the manifold. So we met with John Belding, PE, over at the AMC, and the few safety concerns he had is to make the support collapsible, so if she falls over, she doesn't get impaled, and to have it light and low impact, so it's not creating a pressure point on her. And he also said to be aware of any repetitive motion and avoiding single pressure points in the design for her wiggle.
Okay, and so for our valves to cover the holes, we found a bunch of different materials and we were testing them all out, and that was part of our mock-up. And we tested 1/2-inch and 1/4-inch neoprene balls and 5 different barometers of neoprene. And we also had a ceiling foam, I guess we call it. And we also tried rubber door stoppers, like little rubber domes. And these are the different ABS cements and things that we found to try and connect Drew's design to the recorder, because we're thinking about machining or printing it out of ABS.
I'm James, and I did the mock-up. We made this wooden contraption so we could test the materials that Rob just talked about and see how far we'd have to move them for them to plug and unplug the holes. So we would tape each material to the end of the screw, and then we'd screw it in until it was completely plugged up, and then we'd unscrew it until it was unplugged, count the threads and get the distance from that, see how far each one moved. And then down the right is a mock-up that we had early on that Luke made, but we scrapped that pretty fast.
I'm Lucas, and I researched instrumental ergonomics. And in order to play any instrument, there's 2 things that you have to do. You have to have a spatial relationship between the player and the instrument. So, for example, holding the quarter at a 45-degree angle. And also the player has to manipulate the instrument in order to produce sounds. And so there's many improvements on woodwind instruments, such as neck straps, supports, posts. And so we went with that with our pose. And so there's proper ways to play an instrument. You have to have proper posture so you can breathe in deeply and you get more air so you can play properly. And there's something that every instrument player has to deal with, which is repetitive stress injury. And this is something that we have to pay special attention to because she's so young and we don't want to add more stresses to her so she has more injuries. And so there's ways to prevent it, and many of you know before you play anything, you have to warm up the joints so they're not cold. This will reduce injury, but what we focused on mainly was while she's playing, because we can reduce some of the stresses that she undertakes. And some of the stresses that we could reduce was, which is one of the most important, was that she could rest when she's not playing, because she can't hold this position for the whole time she's playing, or she's going to have added stresses on her shoulders and other joints, and that would be bad because she's so young and it could bother her later on in life. And some other things was we put a post in so that way she can pull up her hands so she didn't have to hold that. Another way was reducing the weight, so we wanted to make our designs as low weight as possible, so the less load, the less stress is on her joints. Also, repetitive motion, as Ian was talking about with the PA, if she's moving her joints back and forth the whole time, that's going to add more stress to her joints. So we try to apply all this to our designs, and this is everything that we ran into designing our product. And are there any questions about it?
How does she manipulate the keys or the holes in the manifold? How does that operate?
So we looked at the pattern of the last 3 holes and just figured if we put them in a triangle, then you could like cover up 2 on one, cover up 2 on the other, or cover up all 3. And that handles pretty much all your note combinations except for the half holes. And so the idea was to put it in a location where she could rock her hand over in certain combinations to get the desired result.
On that manifold, as far as manufacturing it, are those through holes, are they straight or are they kind of curve around there?
Originally they were straight, kind of like angled, but we decided that we wanted to have the cross section be constant radius all the way through. So it's actually, you can imagine, like the hole starts at, let's say, 1/8 of an inch, and then it kind of follows a path all the way around like that. So it's actually a swept cut.
Is the plan to just have a high resolution print that can do that?
3D print, yeah. It would really, I can only think of doing it with a 3D print. I'm not sure how else you would do that.
Does the location of the hole change, I mean, from where they are? Is that gonna potentially change the note?
It will potentially change the note, but we figure that there's a certain diameter for each hole that will allow the tuning to remain consistent.
So it sounds like you're gonna have each of the holes a different size, is that,
That'll have to do with testing. We're not really sure exactly.
so how does this, the whole manifold system affect teaching Nye how to play it? Have you-
It'd be the same as any other of our recorder contraptions, I guess. It's going to be something new for her, but it'll be a variety of just, do you cover these two or these two? In fact, it would actually be a lot like teaching a regular person to play a regular recorder, because you're just covering holes. So in this example, you're just telling her to cover the same holes. It's just that it's easier for her to access them.